Alrighty. Oh, I should mark our attendance. I always love when I remember to do that. I mean, bro, come on. It's not plugged in, dude. Why are you turning on a fan? It's like 10 degrees outside. No.
She said she was hot.
No. It's not. It's like 4 degrees outside, my dude. Let's see, wait. 7 degrees outside, my dude. Just saying. Also, if you move my stuff, put it back. I mean, come on. It happens every day when someone touches that fan. They leave it in the middle like it's some sort of statuette that we're putting in our tables. So otherwise I'm going to start hiding my stuff and only using it when I want it. 1, 2, 4. Love it. That's everybody. So much easier. Okay. So what we're going to do today is it's really similar to our simplifying that we did yesterday, but now it's verifying simply because there's equal signs. So we're trying to make the left side match the right-hand side. So it gives us a clearer goal other than simplify. So I feel like these are easier than what we did yesterday because I can see where I'm trying to go. I want the left side to match the right side. So we're only going to play with one side. So if it helps, you can always come and put like old school back when we did and like, number 1, put the little wall. We're not crossing. We're not going to do operations on both sides. We're just going to use rewriting it into sine and cosine and using our identities that I still have on the board, but just know that they're not going to be on the board when it comes time for like quizzes and stuff. So we need to know those.
We got to memorize them?
Yep. So we're going to play with these and we're going to verify making our left-hand side match our right-hand side. So our first one, we've got this cosine theta, secant theta. And what I'm going to do is I'm going to come in and I'm going to rewrite secant in terms of sine or cosine. So cosine theta is just, cosine. Secant, how can I write that in terms of cosine and sine? 1 over cosine. These two pieces are multiplied together. What happens? The cosines cancel. One's on top, one's on bottom. So when they cancel out, what does it simplify down to? 1 equals 1. So we've got that the left equals the right. And we have verified. Ta-da! You didn't even have it pointed at you, dude. Put it back in the windowsill. It's almost like that's meant for springtime when we can open the windows and get fresh air in here. Because the air in this building hasn't changed in like 20 years. Okay, so that's what we're doing. We're trying to get the left-hand side to match the right-hand side. So on this one, we have sine secant equaling tangent. Same thing. I'm only going to play with the left-hand side, trying to get them to match up. Sine theta is secant theta, and I want it to equal tangent theta. So I'm going to rewrite them both in terms of sine and cosine. Sine of theta is just sine of theta. How do we write secant theta in terms of sine and cosine? What is secant? 1 over cosine. All right, sine of theta times 1 over cosine theta. We can multiply those together. Sine theta over cosine theta, right? Sine over cosine is also known as tangent. So now I have tangent equals tangent. And our left equals the right. So it's been verified. The left-hand side matches the right-hand side. That's what we mean by verify. We're trying to make a match. The third one up here is the very same vibe. Very same vibe. All right, so I'm going to give myself my little wall again. And if you don't like the little wall, if it's not helpful, you don't have to draw it. That's not a math thing. It's just a visual thing for me. So we have a fraction here where I have cosecant. How can I write cosecant in terms of sine and cosine? 1 over sine. And how can I write secant in terms of sine and cosine? 1 over cosine. Right? If we have two fractions that we are dividing, what's the other way I can write that? How? Multiply by the reciprocal. So I can rewrite this as a multiplication problem. That is, I need a different color because they're going to move together. So I have 1 over sine theta times the reciprocal, so we need to flip it, cosine theta over 1. I'm going to multiply those. So we get cosine theta over sine theta. Cosine over sine, also known as cotangent. Cotangent equals, and if we look, that's where our goal was, cotangent. And we have verified this. Left-hand side equals right-hand side. Okay, so we're just kind of playing with them like Play-Doh. Smushing them around, trying to make the left-hand side equal the right-hand side. And whenever we have something like a 1 or a tangent or a cotangent, something that we know and can spot right off the bat, I recommend not changing the right-hand side at all. Just play with the left-hand side, or whichever side is crazier. Okay, so we're going to do a few more of these, just like this. This is what we're working with today, but you know how it goes. They're going to get a little crazier. Speaking of, I promise it looks wild, it's not. So we've got the quantity 1 plus sine x times the quantity 1 minus sine x is 1 over secant squared x. So write it down. And the one thing, I want to fix first the right-hand side, that 1 over secant squared x. I'm not entirely sure where we're trying to get, because 1 over secant squared is kind of tricky to wrap your brain around, right? So before I go too hard into that parenthesis side on the left, let's look at the right. What's another way I can write secant again? So 1 over cosine, so this is 1 over cosine squared. Right? But if I have a division by a fraction on the bottom, what does this really equal? 1 over cosine. When we simplify that, what's it going to be? Cosine squared. So our goal is to get this to be cosine squared of x. That's our whole goal. So if you get something and you can't tell where you're supposed to be, switch it around into your sines and cosines until we can figure out what the heck the goal is. For the most part, it's going to be that we only have to play with one side, but if they give you something crazy on one side, fix it so it's less crazy. So our goal is to get this left-hand side to look like cosine squared x. What's your instinct when you see something like this on the left, other than cry? Multiply it out. Absolutely. Distribute this. Multiply this guy out. So we're going to have 1 times 1, 1. 1 times minus sine x becomes minus sine of x. Sine x times 1 becomes plus sine of x. And sine of x times minus sine of x gives us minus sine squared x. What happens when we simplify? Because these two signs cancel out. I have a plus sine x and a minus sine x. We get 1, let me get it on the line. 1 minus sine squared of x. Because this pattern up here, if you think about it, if this was 1 plus x, 1 minus x, the difference of squares. Difference of squares. Okay? So now we have a sine squared thing, and we're trying to get to cosine squared something. We're going to need to head over into our identities to try and find one that might help us. So that very, very top one, our first Pythagorean identity, has both a cosine squared and a sine squared in it. So that one's probably going to be super helpful. So I'm going to write that one down. That was my sine squared x plus cosine squared x equals 1. What can I do with that to help me here? This is it's a separate thought. So I'm going to give us a little barrier here. Yeah. I want to see if I can make a piece that looks like this. I would like to have 1 minus sine squared x. So if I subtract sine squared x from both sides, we get cosine squared x equals 1 minus sine squared x. And we have here a piece I can use in my substitution. So I have 1 equals sine squared x equals cosine squared x. So I can come up here and I can substitute this in. 1 minus sine squared x is the exact same thing as cosine squared x. So we're going to wind up using the identities as like a substitution to help us make things line up the way we want them to. When we do that substitution here using our identity, so I'm just going to put identity. Using this guy, we've got that our left side does in fact equal our right side. We wound up back at our cosine squared x. And I told you these get a little weird. Put questions on this one. Once we can get our brains wrapped around them, they're not awful. But you look at them and you go, oh. So they're super scary to look at. They're very impressive. If you want to show off your skills, these are very impressive. Because no one outside of high school remembers how to do these. So it's a really good show-off skill. Everybody's like, I remember that. I could do that. Yeah, give them trig. All right, next one. I've got secant x minus cosine x equals tangent of x times the sine of x. And again, they gave us kind of wild stuff on both sides. So we're going to actually have to work both sides this time because it's a little weird. I'm going to sit down because my handwriting's trash when I stand up. So what we're going to do is I'm going to take the whole kit and caboodle, everything here, and we are going to write it in terms of sines and cosines. So my secant, how do we write that in terms of sine and cosine? 1 over cosine. Minus cosine, he's just hanging out, equals tangent, how do we write that? Sine x over cosine x. And this is times sine of x. All right, let's simplify one side at a time. So, just looking at this side, what can I do over there to simplify that? Not that. I didn't even touch the screen. Grumpy computer. Yeah, sine squared of x, or sine x squared. So this right-hand side we can write as sine squared x over cosine x. Means the same thing, sine of x times sine of x. On the left-hand side, I've got some subtraction going on here. What do I need to do to be able to do this subtraction? Common denominator. What am I going to need to multiply this guy by to get a common denominator? Cosine over cosine. So we're going to wind up with 1 minus cosine squared x over cosine. And what can I do with that? Turns into sine because of that first Pythagorean identity. Very much like how we did it on the last one. If I take my sine squared of x plus my cosine squared of x equals one identity, that first Pythagorean identity. And this time I get my sine squared by itself. Sine squared of x equals 1 minus cosine squared. I can take this chunk and replace it with sine squared of x. So we have sine squared of x over cosine of x, or drop the x here. And that equals now sine squared x of cosine x. And we did it. We verified that secant minus cosine is the same thing as tangent times sine. How we feeling on this one? I feel like it's easier when there's a goal. The simplifying one, it just feels untethered because we don't know where we're supposed to go. And this time there's a goal, so we have a target. Once we get there, we know we're done. So I always like the verifying better than the just straight up simplifying where you go, I think I'm done. I don't know. What the heck just happened there? There we go. Why did half of me disappear for a minute? Okay, the next one's gonna pull in a little bit of review and it's gonna look super cray. And I promise it's like a 2-step. Okay? At most. Pulling in some logs. Logarithms. This is the log of tangent of theta. And we want to know if that equals the logarithm of sine of theta minus the log of cosine of theta. Honestly, it might take you longer to write it than it will take us to do it. But honestly, we're doing okay time-wise today. Like, we only have one more after this, I think. Yeah, there's only one more after this, and then we'll have time to work. Like, what? Oh my gosh. Work time in this class? Who'd have thunk it? I know, it's very rare. It happens like once a month where we get time to actually work a class. But it happens, okay? All right. What can we do here? Yeah, we're going to look at the right side. And log functions, when we have a subtraction, we're going to condense it. When we condense a logarithm, what am I doing with that subtraction? Dividing. So this becomes the log of sine theta over cosine theta. Oop. If I was to rewrite tangent in terms of sine and cosine, what is that? It's sine over cosine. So log of sine theta over cosine theta. And we did it. We don't have to find values. We're just making a match. So it looks scary, especially when they throw logarithms in there on us on these trig functions. But I promise they're not awful. The next one is long simply because it takes width. Okay? So like when I did this in the notebook, I wrote small and it goes all the way edge to edge. Just so that you're aware. If you are a big writer, it might take a couple of lines. Okay? This is our last one for the day. So we've got our cotangent theta plus cosecant theta times the quantity tangent theta minus sine theta equals secant theta minus cosine theta. And the right-hand side are standard trig functions, so we're just going to play with the left-hand side. There's nothing crazy going on. It's not 1 over secant. It's not anything wild. So we're just going to play with the left-hand side. What can we do? What's your instinct when you see 2 sets of parentheses like this? Distribute it. 100%, that's the plan. We're just going to be careful about it because we're taking cotangent theta times tangent theta. We're going to take cotangent times minus sine theta. So minus cotangent theta sine theta. I don't like that blue. Then we're going to do cosecant tangent. And get one more piece here. Told you it was wide. Minus sine theta cosecant theta. And this all still equals our secant theta minus cosine theta. We're just going to keep the right-hand side like it is, and we're just going to kind of drop it down as we need it. All right, so what we're going to do is we're going to take each of these pairs and put them into terms of sine and cosine so we can see what the heck we can do. So I'm going to start with my left-hand one, my purple one, with cotangent, tangent. How do I write cotangent in terms of sine and cosine? Yeah, I was going to say you can do 1 over tangent, and if that one works for you, that one works too, because you're going to wind up at the same place. I would rather put it in terms of sine and cosine, so I'm going to put my cosine theta over sine theta, and my tangent as sine theta over cosine theta. Do you guys want to simplify in chunks, or you want to write it all out and then go through and simplify? Write it all out. Great. Sounds like a plan. So then let's do our green one. We're going to write that out. Cotangent times sine. Cotangent, that's our cosine theta over sine theta times sine theta. That one's worse. I'm trying to get a decent, there we go, decent theta. We can read it. All right. So then we're adding our cosecant plus tangent. Cosecant, also known as 1 over sine of theta. Tangent being sine over cosine. And then we have our sine theta cosecant, which is 1 over sine theta. And we're going to come in and we're going to simplify each of these chunks. So I'm going to change my view in just a second so it zooms in so we can actually see what the heck I have here. I'm going to give you guys a second more to write because I see a lot of people still writing. And we're going to come in and simplify each of these things, each of these chunks. All right. So we're going to look at just the purple piece here for now. Cosine over sine times sine over cosine. What happens? They cancel out. My sines cancel out, cosine cancels out. So what does this simplify down to? 1. Thank you. Then let's look at our green one. Cosine theta over sine theta times sine theta. What happens? The sines cancel out, and we're left with minus cosine theta. On our next chunk, the sines cancel out. And I have 1 over cosine theta. And on the last one, the sines cancel out, and we're left with minus 1. So that was a whole lot to get down to 1 minus cosine plus 1 over cosine minus 1. Keep going. What else can we simplify here? The 1's cancel out. I have plus 1 minus 1. So we're left with minus cosine plus 1 over cosine. It's addition, not multiplication, so they don't cancel. I know we've so we're going to need to common denominator it. Let me get a different color so it stops blending. So we're going to take our negative cosine. Oh, actually, wait a minute. Look at our goal. I'm just trying to get minus cosine. Don't lose track of what we're trying to get. Secant minus cosine. I have minus cosine. Right? What's 1 over cosine? Secant. So we don't have to necessarily common denominator it. Remember to check where we're trying to get. So I have secant theta minus cosine theta. We got into a groove and we tried to keep on going, which is fine, but then we're just going to have to go fluff around the right-hand side and make it match what we got to. Okay, so I appreciate, we are sometimes in a groove and we just want to keep on going and get it down to a single thing because we're awesome like that, which is fine. But then you're going to have to go make your right-hand side match. Okay. We have 10 minutes. We have 10 minutes. This is 6-2B. You guys should be able to do everything on there, I think. There is another section of 6-2 for us yet to go. All of this was one thing. Starting from the identities. We are not going to start 6-2C right now. Oh, no. It was starting from the unit circle to here is still all one section. And that's crazy. It's crazy. So that's where the benefit of being with me is, because I'm not organized enough to deal with late